Hi, this is Physics Unit 1, October 2018. So let's start. Number 1. Which of the following quantities could have units of Newton meter per second? So in number A we have gravitational field strength. So gravitational field strength is actually from the formula weight equals to mg. So W equals to mg. If we make g the subject, we will get W by m. W is weight, right? Weight is in newtons and m is mass. Mass is in kg, so Newton per kg. So this does not match with this, so this is not the answer. Part B says that gravitational potential energy. So the gravitational potential energy is GPE, right? So GPE is equals to mgh. So mass is m kg, g is this one, Newton per kg, and this is in meter. So this will cancel out, we will have Newton meter. So this is also not the answer, A and B. Let's see C. Power. Power is energy by time. So energy is actually this. The GPE is a form of energy. So energy is Newton meter by time. So Newton meter by time is in seconds. So Newton meter per second. So C is correct. So C is the answer for number 1. And part D, work done is also a type of energy. So the units for work done is Newton meter, same as the GPE. So the answer to this question is C. Number 2. The equation del W equals to F del S can be used to calculate the work done on an object by a force. Each quantity in the equation can be described as either vector or scalar. So what is scalar? Scalar is any quantity which has only magnitude but does not have any direction. For example, time. Time can be 1 seconds or 2 seconds, 5 seconds, 10, 15, 20 seconds and so on. But vector quantity is something that has both magnitude and direction. So magnitude is basically any type of value and direction is the direction that we know of. For example, if we have a displacement, an object would be moving at 5 meter per second speed, so that speed is a scalar quantity. But if we say that an object is moving at 10 meter per second at a direction due north or at a direction due south or at a direction 30 degrees due east, so this has a direction, right? So this is a vector quantity. So a vector quantity is one that has direction. So work done is basically force into the direction of the distance moved. So a force is a vector quantity and the direction is also a vector quantity, since this direction is involved with the direction of the force. So we also know that vector into vector is scalar, which is this, and work done is a form of energy and energy is a scalar quantity. So work done is a scalar quantity and force and direction are vector quantity. So the answer to this question is B. Number 3. A spring is suspended from a bar. A load of 2.5 Newton is added to the free end of the spring and the spring extends by 4 centimeter. So the spring is extended from the bar. So this is the bar and this is the spring, and for 2 newtons the extension is 4 centimeter. Then the load is increased to 10 Newton and the spring extends by a further distance x. So this is the distance x and the total distance is this. The total distance moved. So we need to find x. So if we can calculate the total distance, we can then calculate x. So we have the formula F equals to kx, where F is the resultant force, k is the Hooke's constant or spring constant, and x is the extension. So we have 2.5 and 4. So we have 2.5 Newton equals to k into 4 centimeter. So the value of k would be 2.5 by 4. So the value of k would be 0.625 Newton per centimeter. And then we have 10 Newton. So F equals to kx. F is 10 Newton and k we have found it to be 0.625 into x. So the value of x would be 10 divided by 0.625. So the value would be 16 centimeter. So this value, the value marked with red ink, is 16. So the value of x plus 4 centimeter would be 16 centimeter. So x plus 4 would be equals to 16. So x equals to 16 minus 4. So the value of x would be 12 centimeter. So the answer to question number 3 is 12 centimeter, which is C. Number 4. A student takes measurements to determine the density of a metal in the form of a long thin wire. Which of the following gives the equipment he should use? So, if we want to calculate the density, we need to know the mass and the volume of the object. So the mass will be in kg and the volume would be technically area into the cross-sectional area into height. So since this is in the form of a long thin wire, this should be a cylindrical shape like this, and it should be a cross-sectional area like this. So to find the cross-sectional area, we need the radius, and to find the radius we need to determine the diameter. So to find the diameter, we need a micrometer screw gauge. So yes, this micrometer, this is a meter rule. So these are the micrometers we need to find. We do not need vernier calipers because it has a precision of 0.1 meter, and a micrometer screw gauge has a precision of 0.01 meter. And since these diameters are very small in length, we cannot use vernier calipers, we need to use micrometers. And we also need the height. For the area, we need to know the radius, and to know that we need a micrometer screw gauge, and to find the length, the height that we are talking about here, we need a meter rule, since it has the perfect range for measuring a wire. And for the mass, we need a top pan balance. So we need a top pan balance, a micrometer, a meter rule, and a micrometer. So this option contains all the three. So this is the answer. Option A is the answer for number 4. Number 5. A box is pulled up a ramp using a rope as shown. So this is the rope, and this part is the ramp, and it is pulling up. This is the man is pulling the box up at a constant speed. So at a constant speed, we know that when there is a constant speed, there is zero acceleration, and since F equals to ma, since there is zero acceleration, the resultant force would be also zero. So the forces acting in the ball are the weight of the box. So the weight of the box will always be downwards towards the gravity, and frictional force on the ground. So the friction force will be to the opposite direction of motion. So this will be the frictional force, and tension in the rope. So the tension in the rope will be in the direction of the man. So this will be the tension in the rope. And normal contact force. So normal is basically at right angles. So this is normal. So at right angles to the surface would be this. This would be the normal and this would be the tension. So let us see, select the diagram which represents the free body force diagram for the box. So these two are incorrect since the reaction is in the upward direction, not at an angle. Since this ramp is at an angle, the normal to the normal to the ramp would always be at right angles to the ramp. So it will look something like this. So B and D are not correct. And let us see A and B. So for A and B, we have the same diagram is used, but for option A, this tension has a greater length than this tension, and we can notice that option A, the length of friction is smaller than length of tension, and here the friction and tension cancel out. So if the friction and tension cancels out due to the same length, the reaction and weight should also cancel out, since it says that it is moving at a constant speed. For constant speed there would be zero acceleration, and for zero acceleration there will be zero force. So this scenario is not causing a zero force. Let us see this one. So the weight is downwards, and this force, and the weight is downwards, and the tension is greater in this direction. So since the tension is greater in this direction and force is smaller than the tension in this direction, so the reaction is in this direction, so that the horizontal components cancel out. So the horizontal component of tension in the right hand side is equal to the horizontal component of the force plus the horizontal component of the reaction, and the vertical component of this reaction, is equal to the vertical component of the weight. So the answer to this question is A, since all the vectors cancel out here, but all the vectors do not cancel out in C. So the answer to this question is A. So number 6, a student drops a small solid sphere through a liquid of viscosity N in a measuring cylinder. A small sphere of volume V falls at terminal velocity through the liquid. A larger sphere of volume 8V is made of a different material. So if a different material is used, it might have a different density. The larger sphere falls through the liquid at the same terminal velocity. The friction force acting on the small sphere is F. What is the following? Which of the following is the frictional force acting on the larger sphere? So we have frictional force F equals to 6 pi N. N is the viscosity, R which is the radius, and V which is the terminal velocity. So 6 pi is constant, V is constant, and we have the force in one scenario it is F, and we have to calculate the force in the next scenario, and the value of N is also constant, so the value of R is varying. So we see that a larger sphere has a volume of 8V. So we know that the formula of a sphere is 4 by 3 pi r cube. So if it is 4 by 3 pi r cube, 8V would be 4 by 3 pi 2r cube. Since 8V would be 2 cube would be 8. So 8 into 4 by 3 pi r cube. So at the end these two should be equal. So the value of r would be 2. So if the value of r doubles, so F equals to 6 pi nRV into 2, there will be, like this 2, there will be 2 on the other side. So this will be 2F for the new scenario. So The answer to this question is C. Number 7. If the liquid is cooled, the terminal velocity of the spheres would change. The terminal velocity of the spheres would. So we have F equals to 6 pi nRV, where F is constant, 6 pi is constant, radius is constant, and we need to take a look at the value of n and the terminal velocity vt, since frictional force equals to 6 pi into viscosity into radius into terminal velocity. So if the liquid is cooled, then it tends to become a solid. It has a change in property which is going to be a solid, since if we keep cooling the liquid it will become a solid at some point. And a solid has a higher viscosity since it resists a, a motion. It resists a motion in the material. So the value of n would increase since the viscosity is increasing. Since the viscosity would increase, the increase in viscosity would lead to a decrease in terminal velocity to keep the frictional force constant. So the terminal velocity would be decreasing and the viscosity would be increasing. So the answer to this question is B. Number 8. A ball is dropped and caught after the first bounce. The ball takes 1.6 seconds to reach the ground. From what height was the ball dropped? So it is a SUVAT equation, SUVAT, where S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time. So we need to find the height. So we need S. We have the initial velocity, which is 0 since it was dropped. Since the ball was dropped, we have initial velocity of 0 and we do not have final velocity. We also have acceleration, which is the ball is dropped on earth, so the acceleration would be g, and the time would be 1.6 seconds. So the equation will be s equals to ut, s equals to ut plus half at square. So s would be the height, so s equals to u is 0, t is 1.6 plus half into 9.8 into time is 1.6 squared. So the value of s would be 12.56 meter. So 12.56 meter rounds to 13 meter. So the answer to this question is B. Number 9. Which of the following is the velocity time graphs for the motion of the ball? So the ball is dropped, right? The ball is dropped. So for example, this is the ground and the ball is dropped from this point to the ground. So when it is dropped, the velocity is 0, right? So the velocity is 0, so the velocity is, so this is velocity and this is time. So when the ball is dropped from this position, there is constant acceleration due to gravity, since F equals to ma. Since there is a constant acceleration, there will be constant increase in speed. So the speed would be increasing, and at a point when the ball hits the ground, it will immediately, the speed of the ball will immediately be 0. So it will become 0, and the ball will then attain speed again, but it will be moving in the opposite direction. So since immediately it will become 0 and it will have a speed, but the speed will be in the opposite direction. So the opposite direction, for the opposite direction, the velocity would be minus. So it will be like this, and slowly it will decelerate, and when it will go to its highest height, the velocity of the ball will again become 0 and it will start to fall again like this. So graph would look like this, since the velocity of the graph would just become 0 as the ball rises up in the air, and before it goes down it will go to 0. So, and another thing is, this height may be 2h, but this height would be minus h. This height will be greater than this height because some of the energy is lost due to impact. So the distance traveled here would be greater than the distance traveled here. So actually, in the real scenario, the area under the graph of this would be greater than the area under the graph of this. So the answer to this question is B. It is not C, because the area under the graph here is greater than the second, but it will be the opposite. So this is the answer. So the answer to this question is D. Number 10. Two liquids of different viscosities flow through identical pipes. If the conditions are identical, the liquid with the lower viscosity will. So the thing is, the viscosity is actually the resistance to flow. Viscosity is actually the resistance to flow. So if the viscosity is lower, it means that the resistance to flow is lower. So if the resistance to flow is lower, the flow of water will be faster. So if the flow of water is faster, a greater amount of volume of water will travel per second, right? Since this causes the higher rate of displacement, which is the speed. So it will flow at a higher speed since there is lower resistance to motion, so there will be a higher speed, and it will travel a greater volume, transfer a greater volume of liquid per second. So the option is B. The correct option to this question is B. So this was the end of MCQ paper. If this video was helpful, please consider liking the video or subscribing if you like. This will help in both motivating me and supporting me for new content on this channel. So thank you for watching, and see you on the next one. I will be adding the videos on a playlist, so if you are doing unit 1, you will get all the unit 1 videos together, so that if you want to finish all the MCQs at one time, you can just click on the playlist and start watching.